There is a planet out there that breaks every rule we thought we understood about how worlds are made. Not metaphorically. Not in the loose, casual way scientists sometimes say something is surprising or unexpected. I mean this literally. The planet you're about to hear about has forced researchers to admit that our models of planetary formation are incomplete. That something is happening in the universe that we cannot yet fully explain. And the strangest part, we found it by accident. On January 1st, 2026, researchers from the University of Chicago announced the discovery of a world so bizarre, so structurally impossible by conventional standards that it has already begun rewriting textbooks. Its official designation is PSR J2322-2650b. And when you hear what it actually is, what it looks like, where it lives, how it moves, you'll understand why the scientific community responded the way it did. With equal parts awe and confusion. Let's start with the shape. Every planet you've ever seen, every image of Earth from space, every photograph of Jupiter or Saturn or Neptune shares one fundamental characteristic. They are roughly spheres. Gravity pulls matter inward from all directions equally, and the result, over millions of years, is a round world. That's not a coincidence. That's physics. It's one of the most reliable rules in the universe. This planet is not a sphere. It's a lemon. Stretched, elongated, warped at both ends, this is a Jupiter-mass gas giant that has been physically deformed by the gravitational field of the object it orbits. When the James Webb Space Telescope turned its instruments toward this system and began returning data, what scientists saw didn't match anything in the existing catalog of known exoplanets. The tidal forces acting on this impossible object are so extreme, so relentlessly powerful that they have overcome the planet's own self-gravity. The gas giant cannot hold its own shape. It is being pulled apart in slow motion. And the object doing the pulling. That's where things get truly unsettling. The planet doesn't orbit a star the way Earth orbits the Sun. It orbits a neutron star, the collapsed, city-sized remnant of a massive star that exploded long ago. Neutron stars are among the most extreme objects in the observable universe. They pack more mass than our Sun into a sphere roughly the size of a major metropolitan area, maybe 20 kilometers across. The density is almost beyond comprehension. A single teaspoon of neutron star material would weigh approximately 1 billion tons on Earth. This is the dead star that this gas giant calls home. And the planet doesn't orbit this neutron star at a comfortable, leisurely distance. It is close. Terrifyingly close. So close that it completes one full orbit in under 8 hours. Think about that for a moment. Earth takes 365 days to go around the Sun. This world, a world with the mass of Jupiter, races around a stellar corpse in less time than a single workday. It is moving at speeds that would make your head spin, locked in a gravitational embrace so tight that the neutron star is literally sculpting the planet's body with every passing moment. The orbital period alone is enough to classify this as one of the most extreme planetary environments ever discovered. But the orbit is just the beginning. Now let's talk about the atmosphere, because what Webb detected there is unlike anything we've seen on any other world. Most gas giants in our solar system are dominated by hydrogen and helium, with complex chemistry layered through their cloud systems. Jupiter has ammonia ice clouds. Saturn has similar features. Even the ice giants Uranus and Neptune follow patterns we've come to expect from planetary science. This discovery follows none of those patterns. Its atmosphere is dominated by helium and carbon. Carbon in extraordinary, unprecedented concentrations. What does that mean in practice? It means this planet's skies are filled with carbon soot. Dark, thick, swirling clouds of it drifting through a helium atmosphere under the glow of a dead star. This is not a world with white clouds and blue skies. This is a world perpetually shrouded in darkness, its upper atmosphere choked with black carbon particles that block what little light filters through. The visual, if you could somehow survive long enough to witness it, would be nightmarish. Not the romantic, science fiction kind of alien world. Something far more oppressive. Imagine standing in a perpetual storm of soot, the sky above you never brightening, the horizon invisible through the carbon haze, and the massive gravitational presence of a neutron star warping everything around you, bending even your perception of distance and direction. But here's where it gets even stranger. Deeper. Carbon under pressure doesn't stay as soot. At sufficient depths, and the pressures inside a Jupiter-mass world are already extraordinary carbon compresses. It crystallizes. Scientists believe that deep within this gas giant, far below those dark helium clouds, the pressure is intense enough to transform that carbon into diamonds. A diamond layer, possibly planetary in scale, buried inside an alien gas giant orbiting a neutron star. This is not science fiction. This is what the data suggests. Diamond cores and interiors have been theorized in ice giants like Uranus and Neptune before, but the carbon concentration in this planet's atmosphere makes the case here particularly compelling. If those models hold, this world may contain more diamond material than any other object we've ever cataloged. A world of compressed carbon wealth, utterly inaccessible, orbiting a dead star at incomprehensible speed. And none of this should exist. That's the part that keeps planetary scientists up at night. Not just the shape, not just the atmosphere. The entire system defies our understanding of how planets form and survive. Standard planetary formation theory holds that gas giants form far from their host stars, in the cold outer reaches of a protoplanetary disk where gas and ice can accumulate. They can migrate inward over time, but there are limits. There are regions where tidal forces should simply destroy a planet, rip it apart before it can stabilize. This planet is in one of those regions. It should not be intact. It should not be orbiting. By our models, the forces acting on it should have stripped away its atmosphere millions of years ago, and what remained should have spiraled inward and been consumed. Instead, here it is. Lemon-shaped and impossibly resilient. Defying the gravitational death sentence our theories predicted for it. There are hypotheses forming. Some researchers believe this gas giant may be the remnant of a much larger original world, that the outer layers have already been stripped. And what we're seeing is a surviving core that has somehow maintained a carbon-helium atmosphere against all expectations. Others suggest this planet formed after the neutron star was created, that somehow in the debris field left behind by a supernova explosion, material reaccreted into a new world. A second-generation planet, born from the ashes of a stellar catastrophe. Both of those scenarios are extraordinary. Neither has been confirmed. And both require revisions to the models we currently use to understand how planetary systems evolve. That's the scientific weight of this discovery. This object isn't just a curiosity. It's a test case. A challenge. It's the universe handing us a result we can't explain and saying, try harder. The James Webb Space Telescope made this possible. It's worth pausing on that. Webb has been operational for a relatively short time in astronomical terms, and it has already produced a string of discoveries that have forced scientists to revise their expectations about the early universe, about galaxy formation, about stellar evolution. This discovery adds planetary science to that list. The world was previously unknown, not identified, not cataloged, not even suspected. Webb found it by cutting through cosmic distances with infrared precision that no previous instrument could match. What else is out there that we haven't found yet? What other impossible worlds are waiting at the edges of our observational capability, defying the rules we've spent centuries carefully constructing? The honest answer is, we don't know. And that uncertainty isn't frightening, it's the most exciting thing about science. Every time we extend our reach, every time we build a more powerful telescope or a more sensitive detector, the universe surprises us. It presents objects and phenomena we hadn't considered. It reminds us that our models are approximations, that our rules are guidelines, and that reality is under no obligation to respect our assumptions. PSR J2322-2650b is that reminder made physical. A lemon-shaped planet orbiting a dead star. Carbon skis. Diamond depths. 8-hour years. And a shape so wrong it looks like the universe is taunting us. It exists. We found it. And we are only beginning to understand what it means. If stories like this one, discoveries that don't fit the textbooks, worlds that shouldn't exist, science that forces us to start over, if those stories are what get you out of bed in the morning, then you're in exactly the right place. Subscribe. Every week we go deeper into the universe's most unsettling, most mind-bending, most reality-altering discoveries. Because the cosmos isn't done surprising us. Not even close.